in order to save the time, already we write a numerical problem. So, in this numerical problem, what is the numerical problem? Find the values of 51.70 by using the Gauss backward central interpolation formula from the following data. What is the data? Data is the values of x and y is given. At x equal to 50, the value of y is 0.6428, 51, 0.6293, at 52, 0.6157, at 53, 0.6018, and at 54, what is the value? 0.5878. 5878. So, in order to apply the Gauss backward central interpolation formula, just we write a Gauss backward central interpolation formula and construct the difference table. So, first we write a Gauss backward central interpolation formula. What is the Gauss backward central interpolation formula? As we know that, as previous we write a Gauss backward central interpolation formula. Again here we write a what? Again here we write a Gauss backward central interpolation formula by Gauss backward central interpolation formula y equal fx equal y0 plus u del y minus 1 plus u plus 1 u upon factorial 2 del 2y minus 1 plus u plus 1 u minus 1 upon factorial 3 del 3 y minus 2 del 3 y minus 2, and we write one more term because there is a 1, 2, 3, 4, 5 terms. So, we able to find out a fourth order forward differences. So, we write a formula up to a fourth order forward differences. So, here what is the next term? Next term is a u plus 2, u plus 2, u plus 1, u minus 1 upon factorial 4 and del 4 y minus 2. This one is a what? This one is a Gauss forward central interpolation formula. Means there is a need to values of a y0, y minus 1, del 2 y minus 1, del 3 y minus 2 and del 4 y minus 2 and the values of a u. So, how we calculate the value of a u? Now, in the next here, in order to save the time, already we construct the forward difference table. So, because this one is a very easy process to find out a difference table, to construct the difference table. So, already here we, in order to save the time, already we write a difference table. So, here why we choose this one is a x0, this one is a, you say this one is a x0, then this one is a what? This one is a x minus 1, this one is a x minus 2, this one is a x1, this one is a x2, and this one is a corresponding values of a u, because what is the u? U is a u equal x minus x0 upon h, x minus x0 upon h. In our problem, in this problem, what is the x? X is a 51.70, 51.70, and what is the x0? X0 is a 52. So, this one is a 51.70 minus 52 divided by h. H is a what? Difference of a two successive values of x, 51 minus 50, this one is a 1. So, what is the u? U become minus 0.30, minus 0.30. This one is a value of a u. This one is a value for u. So once we calculate the value for u, so here intentionally we choose the x0 as a 52 because we are going to apply the Gauss backward central interpolation formula, and in order to apply the Gauss, once again I repeat this statement, why we choose this 52 as a x0, because we are going to apply the Gauss backward central interpolation formula, and the Gauss backward central interpolation formula give the best values if give the most accurate values if the u lie between -1 to 0, -1 to 0. And here what is the value of u? The value of u is a what? -0.30, which is nothing else lie between -1 to 0. That's why we choose x0 with a what? x0 with a 52. Now in a similar manner, this one is a what? This one is a value of a y0, this one is a y0, this one is a y-1, this one is a y-2, this one is a y1, this one is a y2, and similar manner this one is a value of a, this is the value of a, if we write here equal, this is the value of a del y-2, this is the value of a del y-1, this is the value of a del y0, this is the value of a del y1, this is the value of a del 2 y-2, this is the value of a del 2 y-1, del 2 y0, del 3 y-2, del 3 y-1, del 4 y-2. So how we apply, how we identify which value we are going to use in a Gauss backward central interpolation formula? One way is this one, just write the means in a notation form, what is the value of a first order forward difference, second order forward difference, third order forward difference, and fourth order forward difference. And from here just write the values of del y-1, del y-1, and the value of u. We have already calculated the value of u, and del 2 y-1, we write the value of a del 2 y-1 from the difference table, del 3 y-2 from the difference table, and del 4 y-2 from the difference table. Means one way to identify means which one is a del y-2, del y-1, del 2 y-2, del 3 y-2, del 4 y-2, just we write the values of a first order, second order, third order, and so on, forward differences in term of a notation. And already we calculate the value of a u, and u lie between -1 to 0. So this one going to give a most accurate value if we use the Gauss backward central interpolation formula. So just we put the values of a what? Values of a u and these values means and one another way. It's very interesting. One another way, there is no need to write these values. Just we draw the central line. Just we draw the central line. So this one is a central line. 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 So we are going to use the values which lie on a central line. Central line, and if the value does not lie on a central line, then we choose the value which lie above the central line, or you may say in other word previous to the central line. The value lie previous to the central line. Then if value lie on a central line, then we choose the value of a central line. If value does not lie on a central line, then we choose the value above the central line. If the value lie on a central line, then we choose the value of a central line. Means we are going to use the value of a y0, del y minus 1, del 2y minus 1, del 3y minus 2 and del 4y minus 2. This one is another way to identify which values we are going to use from the difference table in a Gauss backward central interpolation formula. In a Gauss forward, we use the central values and next to the central values. Central values next to the central values. Central values next to the central values. But here we are going to use the Gauss backward central interpolation formula. So just we put the values of a what? Just we put the values of a y and their differences. So here we put the values of a y equal y0 plus what? U del y minus 1 plus u del y minus 1 plus u plus 1 u upon factorial 2 del 2y minus 1 plus u plus 1 u minus 1 upon factorial 3 del 3y minus 2 plus one another term because there is a fourth order difference. So u plus 2 u plus 1 and u minus 1 upon factorial 4 del 4 y minus 2. Just put these values. So what is the values? Y equal y0 is a what? Y0 is a 0.6157. Y0 is a 0.6157. This one is a value of a y0. What is the value of a u? U is a minus 0.3. So here we write a plus, this is minus 0.3. This one is a minus 0.3. Then del y minus 1. What is the value of a del y minus 1? Minus 0.0136. Minus 0.0136. This one is the value of a second term. Third term become minus 0.3 plus 1 into minus 0.3 divided by what? Divided by factorial 2 means a 2. Then we write the value of a del 2y minus 1. What is the value of a del 2y minus 1? Minus 0.003. Minus 0.0003. 003. Now we write one another term, and what is the another term? Plus u plus 2. So here we write a u plus 2 means minus 0.3 plus 2 minus 0.3 plus 1 into minus 0.3 into minus 0.3 minus 1 divided by here we write a not here we are going to write a first what we write this term means a u plus 1 u minus 1. So we are going to write what? This one is a u plus 1 u, and here we write a u minus 1 minus 0.3 minus 1 divided by what? Divided by this one is a divided by factorial 3 means 3 2 is 6 into what? We are going to use del 3y minus 2. Del 3y minus 2 is a what? Minus 0.002. Minus 0.302. So here we write the value of this one minus 0.0002 and write one another term minus 0.3 plus 2 minus 0.3 plus 1 minus 0.3 into minus 0.3 minus 1 divided by factorial 4. means a factorial 4 be the 4 3s are 12, 2s are 24, 24 into del 4 y minus 2. I think what is the value of a del 4 y minus 2? Del 4 y minus 2 is a 0.0004. So this one is a 0.0004. So this one is a what? If we move on a central, here center. So just we put the values of a y0, and the value of a u del y minus 1, the value of a u plus 1 u upon factorial 2 del 2 y minus 1, u plus 1 u minus 1 upon factorial 3 and so on. Then after simplification we get the values of a y at 51.7. So already we simplify this one. What is the result? This one is a, after simplification of a first term we get this one is a y0. After simplification of a second term, u del y minus 1, this one, u plus 1 upon factorial 2 del 2 y minus 1, this term, then u plus 1, sorry, u plus 2, u plus 1, u minus 1, we find this term. After simplification of this one, what is the result? Result is a y equal f of 51.70 equal to this one. So this one is the answer. This is the answer of this problem. This one is the answer. This one is the answer. This one is the answer. So what is the summary of Gauss backward central interpolation formula? The means how we solve any numerical problem. Just first of all, we decide which value we choose as a x0 in order to apply the Gauss backward central interpolation formula. We choose such value of such value as a x0 if u lie between minus 1 to 0. Then we choose the x0 and construct the difference table, and on the difference table we identify the values of y0 del y minus 1, del 2 y minus 1, del 3 y minus 2 and del 4 y minus 2 and so on, and putting these values with the values of a u, and after simplification be able to find out the values of a unknown value of a y for given values of a x if x lie in the mid of a given set of values. So this one is all about of what? Gauss backward central interpolation formula.